Hello people, you are on Topper's Ways and this is the first video of our Dirty Tricks series. As the name suggests, Dirty Tricks, I'm going to do the same thing. This is a question, a very popular question asked in 2007 IIT JEE paper. And the question asks the acceleration of the particle m towards the point P at any separation x. Okay, so this is the basic question and we have four options here. Okay, so I'm going to do this question in 10 seconds. Yes, you heard right, in 10 seconds. So let's find out the way which I'm going to do it. Okay, so the question is this. We are gonna assume the system in different states at different point of time. Okay, so just for example, let's just look at this force F. This force F is given, but the value of F we can choose. We can choose the value, let's say F is equal to 0. If F is 0, then there is no force in this system, and if there is no force on this system, acceleration must be 0. So as you can see in every option, if we put F equals 0, acceleration comes to be 0. Okay, so it's good. Now we are going to look on what part of the options are different. Like this root of a square minus x square is different. Okay, so we will vary x and a to find out the answer. Okay, let's vary x first. Okay, let's assume this particle is moving, and there is a time when the separation becomes 0, like this. Okay, so this separation basically is 0. Now what happens if the separation is 0? All the forces in this horizontal vertical direction, sorry, and the horizontal component of every force is 0, so the acceleration must be 0. Okay, so which term is 0 after putting x equals 0? Let's find out. If we put x equals 0 here, this will becomes a by root of a square, which is a, so 1. So the answer will be f by 2m. It is not 0, so this is not our answer. Okay, for the second part, if we put x equals 0 and x equals 0, this quantity will be 0, and 0 multiplied by any other quantity is 0. So this can be our answer. X equals 0 here, this can also be our answer. And x equals 0 here, this will tends to infinity. So it can't be our answer. So we have two options here, B and C, which can be our answer. So now let's think about the term A. A is the initial condition. Okay, and we have to find in which direction the m has an acceleration. Okay, because of a has some certain value, the m must go in this direction, as you can see, because this is a surface basically, mm, and it is lying on there. Now let's assume a is 0. Let's assume that we have a situation where a is 0. We have asked the question this. Okay, this is our initial question. Then what is the acceleration of these masses? Okay, now what should be the acceleration of this mass? In this direction it should be 0, but it is not moving right now. Don't confuse it with this scenario. In this scenario, the particle was moving in this direction. Okay, so the acceleration was also in this direction. But in this scenario, we have particle force in this direction, so the acceleration must be in vertical direction. We don't, we have not asked to find the acceleration in a particular direction. So here we just put F equals 2ma because the mass is 2m. So this will be the Newton's equation. So the acceleration here will be F by 2m. Okay. Now let's find out in this B and C by putting a equals 0. here in C, if we put a equals 0, the whole term tends to infinity. So this can't be our answer. Okay. Now, in the B part, if we put a equals 0, it will be f by 2m. We can see. So our answer is B. So this is as easy as that. You can just you have just to find out that which term is varying in each options, and then put some values according to you to find out which is the correct option. So this is the way, and I guarantee that you can do it in less than 10 seconds if you know how to do it. And of course, thanks for watching this video. And if you like this video, please subscribe to my channel. Thank you.